So go ahead and grab the lab files and the engine if you need it. So our goal is to make Pong. We're actually on week 8, so this is week 7's lecture because we lost a week because I was out. I hear furious clicking because everyone can't copy the files. You can use the existing engine folder if you have it.
Yeah, I just copied it and it was fine.
Maybe it's because you copied it that everyone else is having. I don't know. You can use the lab from the homework. You can use the engine folder and stuff from your previous homework too, if you want to. There's nothing new about this. There's no graphics or anything, but I just gave it to people if they needed it because they didn't bring it. Hey, Matt, did you bring your homework too? Did you hand me your homework? The Zool?
No.
Okay. Pong. So, thinking about the different components of Pong, we've been working with balls a little bit because that's a big part of it. And understanding how to move a ball is a big part of Pong. However, the other part of it is the player input. So, in Pong, player has authority over his paddle. So what we're going to do today for the first lab is implement the logic so that you can have 2 paddles and you can move the paddles up and down with the arrow keys for one player and W and S for the other player. And I think the first part is pretty straightforward. So the first part is that I just want you to move the paddles up and down when you press the keys. You guys have actually done this because I gave you a lab to move a rectangle when you press the key. Now in this case here, you're going to move the paddles up and down. However, the last part of this lab is I want you to constrain the paddles to the screen, because otherwise SFML doesn't limit your objects to the screen. It will gladly let you move things off the edge of the screen. So what we want to do here is we want to make it so that the paddles themselves aren't allowed to move off the edge. So let me talk about this a little bit. So when we have our paddles in Pong and they're moving up and down, right? So I have this paddle that I can move up and down with my W and S key. What I want to do is I want to constrain this thing so that if you try to move it above the edge of the screen, it stops you, right? That's how Pong works. You can't move above the edge of the screen. Now, there's kind of 2 parts that go into stopping a paddle, or stopping anything really. One, you have to detect that they're trying to do that. Specifically, you have to detect that the paddle is outside the bounds of the screen. Then secondly, you have to do something about that fact. Once you've found out that they are outside of the screen like this, you have to stop that, right? You have to not let them move outside those bounds. So because of those 2 parts, we're going to have to write conditions that say whether or not you're allowed to move the paddle. By default, in the first part of the lab, I'm just going to have you guys move the paddle without any conditions whatsoever. The second part of the lab, the last part really, is before you go to move the paddle, you need to make sure that your paddle is still within the bounds of the screen. So can anyone tell me how you know whether your paddle is above the screen or not? Does anyone know?
Paddle top.
So what is the position of this paddle in SFML? It's right here, right? Yeah. This this top left corner right here, that's the position of the paddle. This little blue circle right here, that's actually where the paddle position is. Okay? If this thing is at the top of the screen here, what is the y component of that blue circle?
0.
0, right? So if you look at the y component of that blue circle and it's less than 0, that means that that paddle, the top left corner of that paddle, is actually above the top of the screen. Which means when the player says, hey, cool, I'm right here at the edge of the screen, and they go to hit W to move again, you have to write a condition that says before you go and move the player, first check to see if their position is already off the edge of the screen. So if they're here, if they're just a little bit off the edge of the screen, what you need to do, you need to not let them move anymore in that direction. Okay? Now, I think going above the edge of the screen is a little easier to detect than what happens if you go down the bottom of the screen. How do you detect if the bottom of this paddle is below the edge of the screen? What is the position of the bottom of that paddle? How do you know what the position of this guy here is? Which I'm going to use green here. How do you know what the position of that point is? How do you calculate what the green position of the paddle is based on the only thing you know is the blue position, but you also know the dimensions of the paddle?
It's just the height.
Get size.
Yeah, what'd you say?
You gotta know the height, like.
Yeah, you take the height, right? You just take the height of the paddle, you add it to the position of the rectangle. Remember, the position of the rectangle is this blue circle. If you take that position and you add the height, you get where the green circle is. Then you can see if that green circle is below the bottom of the screen. And we know that the bottom of our screen is 512. That is what our bottom is. If this is 0, this is 512. So you have to write the same condition for when they're trying to move down, right? So that's number 5, or number 4 on the lab. So when I ask you to constrain the paddles to the screen, that's what I want you to do. So I want you to write some conditions that control whether the paddle can go above or below the screen. Okay? So do that for lab, please. Thank you.